starting something new this week, we are going to be dealing with exponential functions. Now, an exponential function is raised to the x power. Freeze. There we go. Okay, so it's raised to the x power. It has a letter as its exponent right there. Now here, this is how it would actually show up on your star charts, but this is actually a better way of writing an exponential function because it makes it more clear that the b is the only thing that's being raised to the x power, not the a value right there. Your a value is going to be your beginning amount. B is going to determine if your amount is going to increase or decrease. Now, if that b is a number that's greater than 1, then that's going to be increasing or exponential growth. If that b value is between 0 and 1, then that is exponential decay. Now, we are not worried about negative numbers at all right now. It's just going to be numbers that are bigger than 1 or between 0 and 1 right there. Okay, so if you look over here, one more, this is what we're going to use whenever we start talking about word problems. It is the same function that I have right here. It's just got a little bit more going on inside the parentheses. But that b value is the 1 plus the rate. And that is something that we are going to have to come back to here in a minute. So let's go ahead and look down at example 1 and 2. So I want to get some practice with us identifying the a and b values and then figuring out if this is growth or decay. So if I write y is equal to a times b to the x power right up there, I can see that my a value, my starting amount, is 1, and my b value right there is going to be 2. So this is the start, and this tells me we are multiplying by 2 times 2 over and over and over again. Okay, so that y-intercept, or that a value right there, is also your y-intercept. It is your beginning amount. That's how much we start off with. Now this is telling us what we are multiplying by. So if I multiply 1 times 2, now I've got 2. If I do that again, multiply by 2, now I've got 4. If I do that again, now I've got 8. Then I can multiply by 2 again, I've got 16. So what it actually means whenever you are dealing with this problem, if the number is getting bigger and bigger and bigger, so I started right there, okay? If you keep multiplying it by 2, that number is going to get very large very quickly. If you do exponential growth, because that's what this one is that occurs whenever our graph is increasing from left to right. So we read graphs the same way that we read books, from left to right. Okay, so over here is another example. I'm going to go ahead and label underneath my equation. I've got y is equal to a times b to the x power. And I want to remind you guys, and I'm even going to add it up here. The a value is also your y-intercept. Okay, so when I'm looking at this one, my a value is the number on the outside, that's 8. My b value is 1/2. So if my starting value is 8, I'm going to put that right here. That's also my y-intercept right there, positive 8. What this b value says is that we're taking that 8 and we are cutting it in half. So if I cut it in half, now I've got 4. If I cut it in half again, now I've got 2. Keep going. I've got 1. Keep going. 0.25, and let me move this sticky note right here. Divide by 2 one more time. 0.125. Okay. So what's actually happening here is that we started off with 8. It went down to 4, it went down to 2, then it went down to 1, then it went down to 1/2, and it's going to keep going and going and going and going. But here's the thing, this is never actually going to equal 0, because if I have a number, even if it's a tiny number, and I cut it in half, I still have something. It's not 0. If I keep going, it's going to get smaller and smaller and smaller and smaller. So it gets very, very close to 0, but it does not actually equal 0. And that is what this word right up here is talking about, an asymptote, a line that the graph gets closer and closer and closer to, but it never actually touches it. And in Algebra 1, that is the same thing every single time, y equals 0. So I'm going to draw it in on this graph so that you can see what I mean. It's my imaginary line. This exponential equation, this function, is never going to go past that dashed line right there. It gets very close to it, but it's never even going to touch it. Okay, so now let's get some practice actually answering some of those questions. Now remember, this is the general form of what an exponential function should look like. Now if I look at answer A, a lot of people are very tempted to put 5 for the A value right there, but it's not. The A value is actually 1 in this case, and the B value is 5. The reason that is the B value is the one that's being raised to the x power, and the number outside of the parentheses is going to be your A value. Now, since this guy didn't have it, it is basically the same thing as if I had this written. I have the 1 on the outside of the parentheses, 5 is being raised to the x power. Now to determine if that's growth or decay. Now, it is growth if our B value is a number that's greater than 1. 5 is definitely greater than 1, so I know this is growth. It's decay when it's between 0 and 1. Let's do the next one. Okay, part B. I don't have anything outside of my parentheses right here, which means my A value is 1. That's our starting amount. My B value is the number that's being raised to the x power, so that's 0.4. Now, if our number is between 0 and 1, this is decay. I know it's definitely not growth because this number is definitely not bigger than 1. C. This one's a little bit easier because we actually have that number on the outside. My A value is 8, and my B value is the 0.25. Now, to figure out growth or decay, look at your B value right here. If it's greater than 1, it's growth. It's between 0 and 1, it is decay. Part D. 4 is my number on the outside. 2.5 is the number that's being raised to the x power, so that's my B value. And 2.5 is definitely greater than 1, so that's exponential growth. Part E. When I look at this equation, it's easy for me to see that the number on the outside is 100. That's our starting amount. But I want to remind you that B is actually what's inside of your parentheses. So in this case, since we actually have something going on right there, we actually need to add those numbers together to get our B value. I'm going to do 1 plus 0.5 in my calculator, which is 1.5. So the B value right here is 1.5. And I'm going to do this so that you know where we got that information right there. Now, this number is bigger than 1, which means that it is exponential growth. Last one like this. For F, I've got 5,000 for my beginning amount. It's outside of my parentheses. The numbers inside my parentheses is 1 minus 0.10. When I hit enter, that gives me 0.9. So 0.9 is my B value. That is not a number that's bigger than 1. It's between 0 and 1, which means that that one is decay. And you also could have told that by looking at the plus or the minus signs in here. I'm going to scroll back up for a second. When it's exponential growth, you are adding the 1 plus the rate. When it's decay, it's 1 minus your rate. Okay, let's get to the word problems. We're going to identify the A, the B, the R values, and then determine if it is growth or decay. Now, A is the starting amount, start, and B is going to be your increase or decrease. Now, your rate, the R, is going to stand for the rate, written as a percentage, and we are actually going to have to do something to the rate before we can use it. So example 3 says, the population of Johnson City has grown, so it's grown at a rate of 3.2% per year since 1989. The population in 1989 was 25,000 people. So this problem is talking about population, and they told us that they started off with 25,000 people. That was 1989. So that's going to be our A value. Now the B value is actually going to depend on if this is growth or decay. Now in the problem, it said that this is exponential growth. They said it's growing. So which equation I'm actually looking at right here is this. Y is equal to a times 1 plus r to the x power. And remember, this, y equals a times b to the x power right here, that b value is the same thing as 1 plus your rate. Okay, so if b is the same thing as 1 plus my rate, I need to know what my rate is. The rate we have was 3.2%. But you cannot put 3.2 right there in place of r. You need to actually change it to a decimal. And the easiest way to do that is just to do 3.2 divided by 100, which gives me 0.032. Okay, this is the number that we are actually going to use for that b. So if my b is 1 plus the rate, that means my b value is 1 plus the point. B is 1.032. And that's a number that's bigger than 1 growth. Okay, question 4. A tractor has depreciated or a depreciation rate of 19% per year. The original price of the tractor was $29,000. Okay, they said the original price of the tractor was that much. That is going to be our beginning amount. So that's my A value right there. Now we've got to figure out if this is talking about growth or means, then use your phone. You can look up words to figure out what they're talking about, but depreciation actually means that it is going to decrease, which means we are looking at exponential decay. And when you are dealing with exponential decay, the b value is 1 minus your r. So the b value is going to be 1 minus r right over here. Okay. Now in the problem, they told us that the rate is equal to 19%, but we cannot use that yet. We've got to take that 19 and divide it by 100 before we do. So 19 divided by 100 is equal to 0.19. Okay, so since this one is decay, we are doing 1 minus the rate, which was 0.19, in order to be able to find the b value. So it is 1 minus 0.19. When I hit enter, I get 0.81. And that's a number that's between 0 and 1. That's why it's exponential decay. Last example, number 5. You invest $1,000 in an account paying 5.5% interest compounded annually. Okay, so I can see my rate right here, and they said that we invested $1,000. That means that we put in $1,000 into that account. That would be the amount of money that we started with, which means it is the A value. Now, to figure out if this is growth or decay, pay attention to what's happening. They said we put $1,000 into the account, and it is paying interest, which means that it is growing, okay? So we need to use 1 plus the rate in order to find our b value. Now they said the rate was 5.5. We need to take that number, 5.5, and divide it by 100 before we can use it. And if you need to use your calculator, go right ahead. It's going to be 0.055. Okay, so in order to finish finding my b value right there, I do 1 plus 0.055, which means the b value is 1.055 when you add those two numbers together.